Hello guys, how are you? In this video we are going to talk about how to solve problems involving Newton's second law on a massless pulley, where it's supported by a string which is massless again. Now let's draw the pulleys first. So let's say this is a pulley. This is a pulley and there is one mass in this direction hanged. It's like this maybe. So I'm sorry, let me sketch it again. So there is one mass here. Okay, this is a huge larger mass. Let's make it a larger mass, and larger mass, another mass in the other direction. This mass may be a smaller mass. So let's say this is mass 1 and this is mass 2, and the pulley is only rotating. Yeah, this is a mass, so the pulley is only free to rotate. Right now, how do we get the acceleration of this mass? And the tension, here is a tension and there is a tension. Here is mass 1 downward. Now there is a downward force here, mass 1 times gravity. This is the weight of mass 1. In this direction you have the weight of the second mass, mass 2 times gravity. Now to decide the direction of acceleration, so you can decide either way. If m2 is greater than m1, then the direction of acceleration is gonna be like this. If the other case is, then you're gonna have a direction of downward. Now the direction of acceleration, let us assume to be this direction. Now how do I get the acceleration of the system? The thing you do here is you draw the free body diagram. There is here what? A downward force of the weight of the first mass, and there is a tension upward here. The same tension is happening here because this pulley is massless. This is a massless pulley. So the same tension you have upward, and here is what? Here is the weight of the second mass weight. Now, how do you solve this problem? Now you have the net force. The thing that you have to note every time is the net force of this is the difference in weight. Weight 2 times, I mean, the weight of the first mass minus the other mass. The other mass's weight. So this is equal to m2 minus m1, the difference in mass, times gravity. This is the resultant force or the net force. Now, according to Newton's second law, the acceleration is what? The resultant force or the net force divided by the masses. But the system is moving as a single mass. So this will give us what? Mass 2 minus mass 1 is times gravity is the net force, and the mass is the sum of the two masses, mass 1 plus mass 2. That's how you calculate the acceleration. So the acceleration of the system or this pulley is the mass 2 minus mass 1 times gravity over mass 1 plus mass 2. This is the acceleration. Now let me draw it again to calculate the tension. So to calculate the tension, so we can just take either side. So this tension, the tension minus this weight equal to minus the weight of the second mass 2 times gravity, gonna give you the mass 2 times acceleration. Now this is how you do it. Now this equation is very important. Yeah, when you subtract, from this tension, when you subtract the weight, this weight, then you're gonna get the mass 2 times acceleration. Now we have expression for the acceleration above, and so the tension is gonna be how much? Mass 2 times gravity minus mass 2 times acceleration. But the acceleration is this mass 2 minus mass 1 over mass 1 plus mass 2 over times g. Then the tension is going to be the mass 2 times gravity minus mass 2 times the acceleration is mass 2 minus mass 1 times gravity over only here is the over what? Mass 1 plus mass 2 will be the tension. But to simplify, you can multiply this one by mass 1 plus mass 2 over what? The ratio of this. So you can do mass 1 plus mass 2 over mass 1 plus mass 2 to simplify this, times mass 2 times gravity minus mass 2 times gravity into mass 2 minus mass 1, everything over mass 1. Yeah, I can just use this one over this is over mass 1 plus mass 2 is here. Now when you do this, you're gonna get the same denominator, mass 1 plus mass 2. So so when you distribute this, mass 1 times mass 2 times gravity, so mass 1 mass 2 gravity, when you multiply this by that, so plus mass 2 times mass 2 times gravity minus mass 2, when you distribute this, mass 2, you can say mass 2 square, yeah. Again here we have mass 2 squared, so mass 2 times gravity, so minus, how much is this mass 2 times gravity minus that, so plus, it becomes plus mass 2 gravity times mass 1. Now over everything over mass 1 plus mass 2, so that is the tension is equal to, now when you do this, when you do this, what you get is, so mass 1 mass 2 gravity plus mass 2 square, yes, gravity, minus mass 2 square gravity, again gravity, plus mass 2 mass 1 gravity over mass 1 plus mass 2 will be the result. Now this is equal to how much? This cancels that. Mass 1 times mass 2 times gravity, mass 1 times mass 2 times gravity is the same, so the tension is going to be how much? 2 times mass 1 mass 2 times gravity divided by mass 1 plus mass 2. That is the tension. Let us do this with some numerical example. Here we have two masses. This massless pulley on a massless string is just arranged like this. So this mass 2 is maybe 11 kilogram, and this one is 3 kilogram. So there's a tension here and a tension here. The system is accelerating this way. Now you are looking for the acceleration. Now according to the above discussion, the acceleration is equal to the difference in weight, mass 2 minus mass 1 times gravity, divided by the sum of the masses, mass 1 plus mass 2. All right, so this gonna give us the acceleration is equal to mass 2 is 11 minus 3 over 11 plus 3, 11 plus 3 times gravity is 10, yeah, times 10 meter per second square. So this is 8 over 14. The acceleration is 8. 11 minus 3 is 8 over 14 times 10, so that is meter per second square, meaning this is the same as you can do by 2 is 40, or the acceleration is 40 over 7, yes, over 7 meter per second square. So you can see this is some 5 point. So the tension, here is the tension. To get the tension T, so the tension, the mg, this weight, the m2g minus the tension is gonna give you the net force on the mass 2, m2a. So this means the m2g is equal to the tension plus the m2a, then the m2g minus m2a gonna give you the tension. So the tension is supporting the mass 2 into gravity minus the acceleration of the system a, so that is 11 kilogram times 10 minus 5.9 is the acceleration. So this is 11 times this is the same as 3.1. so the tension is approximately supporting, so 33 Newton. So that's how you find the tension. Thank you for watching.